Hello, welcome to another lesson with me. Today we talk about logic and proof. One of the characteristics of mathematics at the higher level is that mathematicians want to see a proof that a particular claim is true. When you say, oh, 1 plus 1 equal to 2, you need to, for mathematician, making that claim alone is not enough. You need to show to other people, that mathematicians or anybody else, that that your statement is logically derived from some other acceptable statement or something that is accepted to be true. So a mathematical proof is a sequence of statements, claims, which are usually which is either validly derived from those preceding it, or is an axiom that is accepted to be true. Axioms are some of the statements that we use in math that are accepted to be true. For example, a point is an object that has no dimension. The shortest distance between 2 points is a straight line, for example. Those are axioms, for example. Okay? So a mathematical proof is is a series of statements which is true. And then when you come to the conclusion, then hopefully that particular conclusion is also true. So proof can be divided into many types. There's something called direct proof and there's something called indirect proof. Right. Let's talk about direct proof. Direct proof basically is about, as we said before, most claim or hypothesis or conjecture are in terms of an implication. If you satisfy certain condition, then you have a particular result. So it's actually an implication. So we are looking at P implies Q. For this type of proof, right, we will assume that P is true. We will assume that P is true, and then we work our way, right? We work our way, through, and hope to arrive at Q. If you can arrive at Q, then you have completed the proof. That is, all the statements is true, leading to Q, then Q must be true. So this is a direct proof. Mathematicians prefer to have a direct proof whenever possible for a particular statement. Alright? So here we assume that P is true and then work our way towards Q. I'll give you an example later on. Alright? And indirect proof. Indirect proof, there are many of them. One is called by contradiction. By contradiction is that in order to prove P implies Q, you purposely go and assume that Q is incorrect. So assume, in this case, assume not P, right? Not P, and works towards a contradiction. If you can come to a contradiction, then in this particular case, right, your statement is true because if the inverse is not true, then the original statement must be true. That's the idea. If the inverse is not true, then the original statement must be true. That's the idea. That's why this is an indirect proof. So you assume the P is not true, and then you work towards a contradiction. The another indirect proof is by contrapositive. That is that in order to prove a statement, in order to prove P implies Q, right, what we do is that we will consider not Q implies not P. That is, you will consider not Q implies not P. That is the contrapositive. And then we assume that not Q is correct, not Q is true, and then works towards not P. If I can establish not P, then I have completed the proof. Then if the contrapositive is true, then the implication is also true. This can be verified. Okay? There's another proof by indirect proof. There's a very famous indirect proof called mathematical induction. We'll learn about this in IB if you're doing higher level. Right? So that's another one.